All right, guys, we're going to go through a few set of notes. And so I want you to walk through this, stop the video, try to answer parts on your own, then check with what the video says. You can rewatch parts. We can take questions on Monday about different parts that we're going over, but I'm going to work through probably 2 or 3 sets of notes in this time. So it'll take you most of the period to watch this video and maybe even a little bit beyond that point. But you have access to continue to rewatch it. But I want to give you enough so you got over the weekend. You've covered enough material to be working through your homework package. So I want you to work through it. If you finish this with time to spare in class, and start working on your homework and do enough so that if you have any questions or concerns about a type of problem, you can come on Monday and ask about those things. All right. So be sure that you have a homework packet. Again, they're always underneath the new packets for the unit that we have. And so be sure that you have a copy before you leave for the weekend. Okay, so we've introduced imaginary numbers, and so we're going to recap just a very little bit of that and then see how we can maybe solve some other types of problems using imaginary numbers. All right, so imaginary numbers, all right, reminder that I is equal to the square root of -1. So that I squared is square root of -1 times square root of -1, which equals -1. Okay, so if we see that in a problem, sometimes we can then convert I squared to -1 to simplify things even more. All right, so in order, if you have I in the denominator, and is represented as a term, we need to use something called the conjugate. Okay, what that means is we got the same terms as the denominator, but we got opposite sign. Okay, we've kind of seen this without realizing what it is before. So we have a plus b, sorry, that's a plus, then a minus b. Okay, those are conjugates of it. Same terms, a and b, opposite signs, 1 plus, 1 minus. Okay, so this is similar to how we had, all right, a plus b times a minus b, okay? And this gives me a squared minus b squared, right? This is the difference of 2 squares. Okay, we're just going from the factors to the problem, and then from the problem back to the factors. All right, so if we're asked to divide and put answer in standard form, remember standard form is a times bi. That means really nothing in fraction form underneath all of it. A could be a fraction of 1/2 or something like that, but we don't want like 5 plus 2i over 4. We want to actually distribute that 4 to each of them, which we'll see here in a second. Okay, so we want to answer in a plus bi form. That's not what it is. Okay, so I'm going to use the technique we just learned about to multiply by the conjugate. So same terms, 1. Now it's minus I, and it's 1 minus I, top and bottom. All right, so then I multiply this out, I get 2i minus I squared. All right, so I just distributed that. And then over, and this is going to be 1 minus I squared. All right, so that's just kind of doing the difference of squares, knowing that that's what's going to be 1 squared minus I squared. All right. And so if that's the case, okay, then we're going to get, I'm sorry, I think this should be 2i times 2i squared, not just I squared. All right, so I can convert some of these things because I have I squared. I'm going to keep 2i because I can't really break that down. And then this is going to be 2 or minus 2 times -1. Just converted that I squared to -1. 1 minus -1. Okay, to convert that I squared to that. All right, so now I got 2i minus -2 becomes plus 2 over 1 minus -1, which becomes positive 2. Okay, so I'm close, but not quite there. And so I could divide each part by 2. And so I end up getting 1 plus I. Okay, because this becomes 2i over 2 plus 2 over 2. And I just rearranged it to have the proper form. So 1 plus I is my actual final answer to this. Okay. All right. For B, same type of thing. We're going to multiply by the conjugate. So we're going to end up with 2 plus I and 2 plus I. All right, so we're going to have to, on the top there, it looks like we're going to have to FOIL things out. All right, so when we FOIL things out, we're going to end up with 2. All right, so 1 times 2 is 2. 1 times I is I. And then we got 2 times 2i gives me plus 4i. And then I times 2i gives me plus 2i squared. Okay, over, difference of 2 squared, so it's going to be 4 minus I squared. Okay. So we can simplify that a little bit, like terms. I got 2 plus 5i plus 2i squared, which is just going to be 2 times negative 1. And I got 4 minus negative 1 again. All right. So this over here, 2 times negative 1 is negative 2. So we got positive 2 and negative 2. Those things will cancel each other out. Okay, leaving me with 5i over 5. Okay. So just want to make sure I'm minus negative 1. Yep, 5 over 5. Okay, which then will cancel out into just I for my answer. All right. All right. So now that we have a better understanding of these things, we can start to identify when we have real solutions versus imaginary. Okay, so solve the following using the quadratic formula. Write any solutions that are imaginary to standard form for complex numbers. All right, so we're just using the quadratic formula like we've done. Okay, nothing's new. Reminder of that, right? I got the x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right. And so remember, we got ax squared plus bx plus c equals 0. So that's where we get those values. So my a equals 1, my b equals 1, and my c equals 1 in this case. That makes things a lot easier. So I got negative 1 plus or minus the square root of 1 minus 4, because a and c are both 1, all over 2. Okay? So I ended up with negative 1 plus or minus square root of negative 3 over 2. All right. So if I simplify this a little bit, I would get negative 1 half rather, plus or minus the square root of negative 3 over 2. Okay. And so, sorry, it shouldn't be negative 3. I'll rewrite that a little bit better. But remember, this can't keep like that. This becomes I times square root 3. And so this becomes the square root of negative, or square root of 3 halves I. Okay. So this is my final answer to this one. Now, because I have I, I'm going to have imaginary numbers. Why? Because I have a negative under the square root. How many do we find? We got 2 answers because we got the plus or minus. Okay. Okay. my answers in standard form that I could answer that too. Now looking over at this one, I see that, well, I can't really use the quadratic formula because it's technically not a quadratic. Okay, so in order to make it a quadratic, I need to multiply each side by x. All right, so I get x squared minus 3x plus 3x over x, which just gives me 3. 0 times x is still 0. All right, so I got my a value equals 1, b equals -3, and then c equals +3. All right, so the opposite of b is just going to give me 3 plus or minus the square root. We have -3 squared is 9, minus 4 times a, which is 1, times 3, which is 12, all over 2 times 1, which is 2. So again, I get 3 plus or minus square root -3 over 2. Okay. But remember, this is going to end up becoming square root 3 times, I'm going to put I in front of it just to make sure it doesn't belong underneath. And so this becomes 3 over 2 plus or minus, I got square root of 3 over 2i. So again, I have two solutions because of the plus minus. I have imaginary because I have an I in there. And for the same reason, I got a negative underneath the radical. All right, so let's try a couple of more here and see what we get already in standard form. A equals 1, b equals 2, c equals 1, opposite of b, plus or minus the square root of b squared minus 4 times a, which is 1, times 1, which is 4, all over 2a. So I get -2 plus or minus square root of 0 over 2. Square root of 0 is 0. So this simply becomes -2 over 2 or -1. X equals -1. So how many solutions we got? 1. Is it real? Sure is. Why? Because underneath the radical was 0. Okay. All right, I got my a equals 1, my b equals 10, my c equals 9. So again, the opposite of b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 9, so 36, all over 2a. So I get -10 plus or minus square root of 64 over 2. -10 plus or minus 8 over 2, which equals -5 plus or minus 4. So -5 plus 4 is x equals -1. -5 minus 4, x equals -9. So I have 2. They are real, and because it is positive under the square root. Okay? So one thing, if you look back at these four a little bit more closely, there's something about a part of the quadratic formula that gives me an insight into how many solutions and if they're going to be real or imaginary. And that is this inside parts, and we call that the discriminant. Okay, so if I look at that and solve that real quickly, I can get a really quick insight into how many solutions and if they're positive or negative, even without all the other stuff. Okay, and so that discriminant means that if I put all those values in and the answer is going to be greater than 0, it's going to be positive. Okay, it's going to be positive. Okay, then I'm going to have real solutions. And I'm going to have 2 of them, right? I see that right above here with number 4. Okay, So this is, again, example 4. Okay. Now, if it is less than 0, meaning I have a negative value, then I'm going to have i's in there, which means I'm going to have imaginary solutions, but I still have 2. This is example 1 and 2. But if I end up getting 0, which is example 3, okay, from the ones above, I end up getting 0, then I'm going to have a real solution, but I'm only going to have 1. All right, so I might be able to bypass, this is a great way on a standardized test where they give you something and then ask you for what are the possible answers. And you have to look through A, B, C, and D. And, you see, well, the discriminant is 0, but 3 of the answers either have all have 2 solutions. Well, if it's 0, it means 1. So you pick the one that has 1. You don't even need to calculate anything if you just know what that is. All right. So again, some more application of this stuff. All right. So let's look at a little bit more closely at solving by factoring. Okay, so a little bit of a reminder of some things that we have done. So again, we are doing it by factoring. We're still trying to put it in standard form. Okay, so we got to make sure that we first set things equal to 0. So I get x to the 5th now minus 9x cubed equals 0. All right, so again, we're going to see if there's a GCF, a greatest common factor, that we could take out. Let's see x in the front, or in the first term, x in the second term. So I could pull out x cubed, and what's left over, I got x squared minus 9 equals 0. Well, I can keep x cubed, but this is the difference of perfect squares, so I get x minus 3 and x plus 3 equals 0. So remember, at this point, to solve for this by factoring, we are solving for it. I got to set each factor equal to 0 and solve. Well, this means that x has to equal 0 for that to be true. X minus 3 equals 0 means that x equals positive 3. X plus 3 equals 0 means that x equals negative 3. So my solutions are 0, 3, and negative 3. All right, so if we take a look at this one up here, okay, well, I got a 2. These are both even, so I could take a 2 out of each, and I could take x to the 4th out of both of them as well. So I get 2x to the 4th. What does that leave me here? Just x. What does that leave me here? 9. Okay. All right, so 2x to the 4th equals 0, and then I got x minus 9 equals 0. This will give me positive 9, and for this has to be 0. So those are my 2 solutions from those two. Okay, so we're getting GCF out of there. All right, but what if we have a polynomial that's got 4 terms? If you remember back to what we've done before, we did this by grouping. So I grouped my first 2 terms together. I grouped my second 2 terms together. All right, so if I look at this first one, what's common? Well, I got x in both. I got a cubed and a squared. Well, I could take an x squared out of it, and that's going to leave me with x minus 5. All right, minus, well, I got a 2x and this. Well, I can't take an x because 10 doesn't have it, but I could take a 2 out. So 2, and what does that leave me with? Just x minus 5. Okay, again, when we group, we do factoring by grouping, what's in parentheses has to be the same. You might be like, wait a minute, this is a plus 10. Where did I get the negative 5 from? Remember that I got a negative 2 out here from this. So if I do negative 2 times x, I get negative 2x like it is. But if I do negative 2 times negative 5, that's going to give me a positive x. So that's how I make sure that I got that as the same thing. So now I take the 2 terms outside of it and put them together, x squared minus 2, and then I take the other term as well. So then I'm going to take each of these and solve for x. So I got x minus 5 equals 0, x equals 5. Okay. I got x squared minus 2 equals 0. I can get x squared equals 2. Take the square root of each. I got x equals plus or minus square root of 2. Okay, so those are my two solutions. Try out number 4 if you haven't already. Well, again, I see only two terms, okay, which kind of make me start thinking this might be a special case, and it actually is. This is the difference of perfect cubes, but again, I got to put it into its a cubed minus b cubed form, okay? And so I got x cubed minus 2 cubed equals 0. All right, so when I got this, this is where I use, okay, this is the difference of perfect cubes. All right, and this is where I use my SOAP. Okay, so remember, that is a minus b times a squared minus ab. Okay, then this is going to be plus, this is going to be plus b squared. Okay, if I take those two terms, I got x minus 2. All right, so it's the same. That's the S in SOAP. And then I got opposite. So I got x squared plus. All right, then I take 2 times x. I'll get 2x. Then plus 2 squared will give me 4. Okay. And so I can set this one equal to 0. And then I get x equals 2. This other one, I'm going to have to do the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4 times 1 is 1 times 4 is 16 all over 2. Okay, so we got negative 2 plus or minus square root of negative 12 over 2. Okay. All right, so I'm going to also make this negative 2 plus or minus, and this is going to become, I'm going to pull out the negative 1 and then reduce down square root of 12 into square root of 4, square root of 3. So it's going to become 2i square root 3 over 2. Okay, so again, I'll do the square root of negative 12 on the side here. Okay. All right, so this becomes negative 1, negative 12, right? That's going to be my I. This I'm going to do square root 4, square root 3. That becomes 2. Can't reduce square root 3 anymore, but I got these guys that are outside of it. So this equals 2i square root 3. That's where I get that from. Okay. So I can reduce this down a little bit and end up getting negative 1 plus or minus I square root 3. Okay. So that is my final solve for. All right. That's x equals. Okay. Hopefully some of that kind of rang a bell a little bit. All right. So this one, quadratics. All right, so this one, they don't look like quadratics because they're kind of in disguise. And so we're going to use our u substitution again. Okay. And so what we're trying to do is to pull something out to kind of put it in that quadratic form of something squared times just x and just a number. Okay, so if in this case we see that, because we're trying to put it in a squared format, well, to the fourth, and I got an x squared here, well, I can let u equal x squared. So this becomes x squared squared minus x times x squared plus 3 equals 0. Well, now, with that x squared, I could just make this as 4u squared minus 8u plus 3. Okay, that looks a little bit more manageable than what we did. So I can do some factoring. All right, so I'm going to get 2u on each side. Okay, got to multiply to 3, add up to -8. So this, and I got positive here, which I go to the middle. It's negative, so both of them are going to be negative. So I don't really have many options here. All right, so I can FOIL it out real fast. I got 4u squared. That's going to be good. I got minus 2u. I got minus 6u. That's going to give me minus 8u. -3, -1 gives me plus. All right, so I'm doing good there. Okay, so now I'm going to set this equal to 0 and rearrange. So I got 2u equals 1, u equals 1/2. I got 2u minus 3 equals 0. Okay, and so I end up with u equals 3 over 2. Now, thing is, I got to put u back in, so I got x squared equals 3/2. I got x squared equals 1/2. Okay, so then from here, okay, once you take the square root of both sides to get x equals. So now this is x equals square root 1 over square root 2. This is x equals square root 3 over square root 2. Now we're not quite done there. And again, these are actually plus or minus. Just took the square root. I got to rationalize it. Okay, so I got to multiply, I'll do a different color, multiply by square root 2, okay, on both sides. Okay, so this is going to equal plus or minus square root 2 over 2. And over here, this is going to equal plus or minus square root 6 over 2. Okay, so those are my two answers. Technically 4 answers on each side. All right, so that's how I'm kind of using u substitution that way. All right, for this one, it's set up a little bit simpler because it's kind of already in a squared value, so I could just make, all right, u equals z minus 4. So this becomes u squared plus 4u plus 3 equals 0. Factor out, I got plus plus. I got u, I got 3, I got 1. It'll add up to 4u, so we're all good there. All right, so we got u plus 1 equals 0, u equals -1. I got u plus 3 equals 0, u equals -3. Well, I got to plug back in. Z minus 4 equals -3. I got z minus 4 equals -1. I add 4 to both sides. I get z equals 3. I add 4 to both sides. I got z equals 1. So those are my answers to this one. All right. Next bit, solving radical equations. Okay, most of this is not as bad as it might look. Okay. So there are some extraneous, which means we're going to have to check. All right. So check to see. Extraneous means that it does not, when I plug it back in, it does not work. Okay. So solutions will plug back in and this expression will be true. And extraneous is I've done the math right. but that solution, when I plug it back in, because of the square roots and things, might actually not lead to a true statement. So those are extraneous. We throw those things out, but we got to check it. Okay, so you see kind of the steps over here on the side. All right, so the first thing it says to do is isolate the radical. All that means is that I just want the radical by itself, so I'm going to have to add 2 to both sides. Okay, so I rewrite this as the square root of 6 minus 3x equals 2. So that's isolating. Then I'm going to square both sides. Squared. Okay, it's a radical and then it's squared, so it just leaves me with 6 minus 3x, and 2 squared is 4. Okay, so I can rearrange. Okay, get x on the right side, subtract 4, so I get 2 equals 3x. Okay, and then I divide by 3 on both sides. Okay, that cancels, so x equals 2/3. Okay, now I want to plug that back in. 6 minus 3 times 2/3 minus 2 equals 0. Well, this becomes square root of 6 minus 2, then minus 2. All right, because this would be 3 times 2 is 6, divided by 3 is 2. So this becomes square root of 4 minus 2 equals 0. So 2 minus 2 equals 0. Check. It works. All right, so try this one out. All right, we got it isolated. Okay, we got the radical isolated, so then we're just going to square both sides. So we get x plus 2 equals x squared. As you might suspect, this could potentially lead to a radical or to a quadratic. And so I get these all on the same side. I'll end up with x squared minus x minus 2 equals 0. All right, so I can factor these things out. So I got x and x. I got minus, so I'm going to have 1 plus, 1 minus, 2 and 1. So I'm going to have that one be 2, that one be 1. All right, so this means that x equals -1. This means that x equals +2. Okay. Plug those back in. Square root of 2 plus 2 equals 2. Yeah, square root of 4 equals 2. That is true. All right, so then I got square root of -1 plus 2 equals -1. I end up with square root of 1 equals -1. Okay, not true. Okay. All right, so that would be an extraneous solution. Okay, so -1 would be extraneous. 2 would be the only solution to that problem. Okay, so I got square root 2x plus 1 equals x minus 1. Well, I'm going to square both sides. I get 2x plus 1 on this side. Then I'm going to have x squared minus 2x plus 1. I just FOILed it out. Then square it. All right, so then I can rearrange. And so getting everything onto the same side, subtract 2x, so it'll give me -4x, subtract 1, and that'll give me 0, essentially. So I end up with x squared minus 4x. Okay, so I can just pull an x out in front. So we got x minus 4. All right, so then x would have to be 0 for this to be true. X is equal to +4. Okay, so I can plug that back in. Start with 0. 2 times 0 plus 1 plus 1 equals 0. I take square root of 1 plus 1 equals 0. Okay. Does that work? Nope, it doesn't. Square root of 1 is 1. Then plus 1. No, that is not working. And then I got plugging in 4. 2 times 4 plus 1. And then plus 1 out here equals 4. All right, so I got 2 times 4 is 8, plus 1 is 9, so square root 9 plus 1 gives me 3 plus 1, that equals 4. That one checks out. Okay, so that's not too bad. All right, let's finish this off. I want to make sure you guys got everything you need to get some stuff done. I know it's kind of a long video, so thanks for bearing with me. All right, so just a quick reminder. All right, so if I have a to the 1/2, this is equal to the square root of a, right? That root is 2. They got 1 on the inside. Okay, but what if I had a to the 2/3? Right, remember where stuff went. I got the 3 on the outside. I got a squared on the inside. I could also write it as the cubed root of a squared. Okay, so just reminding you of how you can set these things up to maybe simplify and help yourself out. Okay, so you see an example right there. Square root of x equals 4 is the same as x to the 1/4. All right, so the goal when solving an equation involving rational exponents is to raise both sides of equation to reciprocal power. All right. So again, reciprocal, okay, is just the flipping of the numerator and denominator. If it's a whole number, it's like, for 81, if that was a whole number, 81 over 1, the reciprocal would be 1 over 81. All right. So just remind you what that actually means. All right. So isolate the exponent. So we want to get that by itself. So we're going to divide by 3 on both sides. All right, so that will then cancel out, leaving me with x plus 3 to the 3/4 equals 27. All right, so then what I'm doing is I'm multiplying each side by the reciprocal. So reciprocal of 3/4 is 4/3. Okay. So what that does is that eliminates these two, leaving me with just x plus 3. A lot simpler. Okay, again, this over here is the same as me saying the cubed root of 27 to the 4th power. Well, this is equal to 3 to the 4th, which equals 81. So this would equal this. So then x equals 78. All right, then it says to check. Okay, and so you want to go back in, put 78. So I get 78 plus 3 is 81. Okay, the 4th root of that, okay, will give me, right, cube root of 81, okay, to the 4th power times 3, okay, ends up giving me 81. So it does check out. For sake of time, I won't show you that, but you can check it on your calculator. All right. And so last one here. So again, when solving for this, if I take the square root of both sides, I end up with x equals plus or minus 2. So just remember that. Okay, so I got it isolated on this side. So I'm going to take it to the reciprocal power, 3 over 2, 3 over 2. All right, that's going to cancel those out, leaving me with x minus 2. And then, remember, this is the same thing as the square root of 9. to the third power. Okay, the square root of 9 is 3 to the third power, gives me 27. Okay, but again, it's going to be plus or minus 27. All right, so then I get x equals 2 plus or minus 27. Okay, so what does that mean? It means I got x equals 2 plus 27, and I got x equals 2 minus 27. So x equals 29, and then x equals negative 25. All right. And so you can plug each of those back in and get 27 minus 2 is 25. Okay, and then you take that to the 2/3 power. Okay, and you end up getting 9. Okay, and so what happens is you take the cube root of 27, which gives you 3, and 3 squared gives you 9, so that checks out. Negative 25 minus 2 gives me negative 27, but the cube root of that is negative 3. Then negative 3 squared is 9. So they end up both checking out. All right. Okay, I know that was a lot. Okay, go back and watch any bit that you need to, but now you got a bunch of stuff that you can actually start working on your homework. So be sure to chip away at that. Try a few problems of each different type so you can come with any questions and clarifications that you have, but you should really have all this filled into your notes on Monday, guys. Sorry I couldn't be there on Friday. Hope you have a great weekend. See you next week.